So these are the key collection types what in Python we frequently use: list, tuple, set, and dictionary, which we already have discussed. Why I kind of chose this before our loop, because then we can use the loop mechanism to go to individual element and then play around with it. That's what our goal here is. But before we jump into the loop, so let's first understand why we need loop. So imagine a simple problem you want to solve here. So you have, let's say, a number. Let's say you have a number called 5. And you want to build a multiplication table. And you can simply do a print statement with num and use the mathematical sign like star is multiplication and then 2. Okay, so this will print 5 into 2 and then so on and so forth. So if you change these values into something like 3, 4, and 5, you will see that it will print 4 values in the screen. So let's see how they look like. So they just print 4 of them. But whenever you see something which is getting repeated, right, in any programming language, that's the trigger for you to really think about how you can reduce those number of characters, which you may build something more efficiently. Okay. The 4 things I did are like printing the same number by multiplying with different value. Okay, there are many ways by which you can optimize this. So programming language is all about writing precise and concise, not writing redundant stuff. So any redundancy should be avoided in programming languages, and that's where the good, let's say, code looks like. So when you read a good code, you will see that they are most effectively written in terms of like number of characters spent over there. And that has been the practice since very beginning, because you might have heard that initially when programming language came with personal computer or the computer, large scale mainframe computers, it used to have something like punch cards. So there are individual cards where you put the characters, and if the more card you have, the more unmanageable it becomes. So optimization in the number of characters were the focus since very beginning. And now I want to change this experience. Okay, I want to leave it here and then change this experience over there in a different way. Now instead of me, you can see that what is changing here are the values like 2, 3, 4, 5. The number remains same, the print remains same. I can optimize this. Now how do I optimize it? So I can probably take either list, tuple, or set, anything. So let's say I say all nums. Okay, I declare a variable called all nums and then put a curly braces, and I put 2, 3, 4, 5. I can even increase it to 6, 7, 8, 9. Okay, so let's put all of them. And then what is my purpose is to print this num multiplied by each element one after another. Now I can do a print statement, put a num, star, all num, and then I can do something like this. So let me show you how I can do inefficiently. Okay, so if I say that print num, that's my 5, and then I say all nums, that's the collection of individual numbers. Okay, and then I say 0th index, that's the first element, and so on and so forth. You can put 1, 2, 3, 4, and then it will similarly print all of them. So that is one way of doing it. But that's again the same thing, repeating the stuff again and again. But I don't want to do that. What I want is that I want to run something we call in programming language loop. So whenever you have to do same thing again and again, you do it within a loop. Okay, and there are a couple of different ways by which you can define a loop. So we'll talk about for loop. So this is the first beginning or the initial kind of loop which you can think of, where you can basically play around with things like going into individual element within a collection and then printing them all one by one. So something on that matter you can consider a loop to be used in a programming language context. So let's say how we define the loop. So for loop starts with a for keyword. So we say for, you can see that it's becoming blue. That's a keyword. So you cannot have a variable declared with a name for, because it's a reserved keyword for Python. So you will encounter this kind of situation whenever you try to declare a variable with the keyword. Okay, so for is one such keyword. Now I can say for I. So I is just a random variable, and this I is in all nums. That's how we declare. And Python is one of the simplest programming language available today, and you can easily interpret what I am writing. So what I'm writing is that pick up each element from all number collection and then do whatever you want to do. So that's the next line instruction I need to give. So I end my for loop with a colon. You can see at the end I put a colon, and that's mandatory. And then I can type print and keep my num. So num is the 5 which is on top, and then I put a star and I say I. Now by doing so, what I'm doing is that I'm doing the same thing which I'm doing above, but instead of writing, let's say, 5, 6, or 9 print statements, I'm writing one print statement, and then it will iterate through all these elements within all nums collection, that is 2, 3, 4, 5, 6, and multiply each one of them with number 5 one at a time. So let's see how that output looks like. So if you notice here in this, if I go ahead and let's say remove all of these, hide them, basically I don't want to remove, and I hide them all together, and I try to run this. So if I do that, now it will give me the multiplication table for 5, and you can see that I literally have 4 lines of code if you ignore those spaces between the lines, because I made them to make it more readable. But if you remove the spaces, it is actually 4 lines of code. Now I can do it with any number. Okay, so instead of 5, I can say that I want to do it for 19. I can just replace it 19, and everything remains the same, and I just go ahead and print them, and you will find the multiplication table for 19. Okay, so that's how you can see. You can also format this with a little, let's say, formatting saying that num into I equal to something like that. So you can also do those things over here. So you know that we have done string formatting. So if you want to format a string, you can put a placeholder and format that string. So you can do all those things. We are not going to do that here. You can always play around and build them by yourself. You can practice it. But this is why we need loop in programming language. And every programming language available today has loop, because we need to do stuff again and again. And when we need to do stuff again and again, we don't need to give that instruction again and again. We can leverage the instruction in a much effective way, and this is why loop is so important. Now, if you go back to our previous day class where we talked about collection, right? So I used one of the collections, that is set. So I used curly braces. So I literally made set. But if you use, let's say, square bracket, that then becomes list. If you use first bracket, it becomes tuple. Okay. So, and then dictionary will be handled differently. But these collection, if you want to iterate through this collection, you can always do that by using a loop, and that's the way to do it, because sometimes this collection can have n number of values. Let's say you have thousands of records in a list. Now how do you know what is the position of a specific record if you don't?
Excuse me, Riju.
Yeah.
I'm getting time and again the same pictures which I have got in the first class. I'm not getting that what you have just taught us. And we have written all these syntax in uh, my page, but I did not find that. Wait, wait.
So is it with everybody, right? Can anybody see what I'm typing?
Please, I'm sharing my screen. I have written the syntax, but I'm not getting that when I'm typing pi first dot pi.
Oh, okay, okay.
Am I doing something wrong?
Uh, so you are trying to run the program on your machine. That's what you're trying to say?
Yeah, yeah.
Okay. And you are not able to run that.
Hmm.
Okay. Share your screen. Let's see what is happening.
I'm sharing.
Yeah.
I'm just. I have already shared it.
Okay, just a moment. Yes. You have a space in the line number 7. You can remove the space. The fir
Oh, line number 7. Again, spell for fastest place to have backspace.
yeah. And then you can just try printing.
Still, I'm getting that for pi first dot. No, again, I'm writing that
No, no, no. You just need to type pi
pi.
sohini.py. Huh? This is the file you are writing code. So you have to
But
print.
I would only write pi or pi first dot pi.
No, 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 no. So the file where you have written the code is sohini.py.
Oh, so he need dot pi. Okay,
So you
okay.
have to type sohini.py. So whichever file you are writing the code,
Okay, okay.
that.
Okay, I've got that. Okay. Yes,
Hmm,
it's down right.
hmm,
Okay, thank you.
no problem.
Hmm.
So let me share my screen. Can you see my screen now? I'm sharing my share. Is it visible to all of you, my share?
Yeah,
Okay, okay. All right. So we talked about that loop, right? So loop is something important, right? And it will come back again and again in typical problem-solving scenario. I want to show you something very interesting here regarding loop. Huh? So let me hide all of these numbers, and what I'm going to do is that I'm going to write, okay, something like my my code doesn't really matter. So become very slow. So I say that India. Okay. So if I say a word like India in a variable called country, and then if I run a for loop, say s in country, what happens? Python programmatically split that word or words into individual characters. And then each character becomes an individual element. So if I now print s, so it will print INDIA all in lines, because print, every new print is a new line. So let's try doing that. So you can see that now it got split into words and then got printed as individual letters. So this is also one of the ways by which you can split things. So if you have to see, let's say, you have to see whether how many vowels are there in a specific set of words, you can split them all in just like this and run through and check whether they belong to any of these A, E, I, O, U. If not, then, or if yes, then count 1 and plus plus plus, and you finally get the total number of vowels present in the any sentence or any set of characters you provide in the input, that is the variable country here. So you can make your own problem and try to solve those problems like this. So that's how you understand how things work, right? Now coming back to the previous state. So let me go back to the previous state. Give me a moment. And then what I'm going to do is that I'm going to hide this, go back to the previous state. Okay, so now I'm back to the previous state. Now what I wanted to do is that I wanted to only, let's say, find the square of whatever number I provide. Okay, so let's assume that the number is 5. Now in this collection, all nums, the number 5 is present, so I'll find match whenever it comes to number 5, and then I will only print that value. Okay, that way whatever number I provide, I can get a square out of it. Okay, out of like 2 to 9, because that's the only set I have in all nums. So that's the problem here. So how to solve that in a typical for loop? So inside the for loop, you can always have a condition. Okay, so you know that we understood a last class that if condition. So if you say if I equals num, now what it essentially says that whenever the value of I is equals num, then only print the value in the print statement. Now to put print below if or under if, you need to put a tab. Okay, so Python uses that concept of having things within. So you can either put a space or tab, so it becomes that. So indentation is important in Python. If you put print at the same, let's say, column of I, then it is part of the for, not within the if. So that's what you need to remember, like whenever you put things between. So now the print is only happening if I equals num. Now let's see what is the output I get over here when I do so. So if I clear it up, and then earlier it was printing all the values, now it will only print 25. Okay, because I have 5 as number. If I change this value to 9, you can see that it will only print 81, because that's what the condition satisfied. So whenever the number matches with the element within the all nums, then only it will print, otherwise it will not print. Okay, so you are basically getting the square of a number by doing that way. So there is a better way to do the square of a number, but assume that this is one of the problem statements you have, and then you have to solve specifically this way. When you put if, you can always put else. Okay, so you can, it's optional. So if I say else, and then in else I simply print not a square. Okay, so I print not a square. Now you notice here it's not a proper tab, so maybe I can put a space here. So it should be properly aligned. Okay, now if I now try to print this, it will print not a square, and go and print 81, because then it finds that it matches with the input number, that is number 9. Okay, so if you change this number 9 to something like number 8 or number 7, then you will get the same output. So you are not changing the overall logic, you are just changing the input, and then it acts depending on how that input is. So you can see that only 49 is getting printed because it's the perfect square. For 7, it finds that matches with 7, and then it prints, and everything else is ignored because I am explicitly printing else. I could omit that, but just to show you that you can also have else in the statement. Okay, like so. I have been doing this number. Now imagine that you have to do this calculation for 1 to 100. So do you really go and type all of them? Do you really go and create a collection of all the numbers starting from 2 to 99? It is quite inefficient. You can, but you can, let's say, misplace a number. You can, because it's typically human behavior, right? So let's see how we can do that. Now Python gives something like built-in collection for this kind of number activity. So let's use one of them. Now, instead of all nums, what I can use something called a range. So I say all nums. I continue to use the same variable, but I define it differently. So there's a very inbuilt function called range, which is available within Python, where I can pass any number. So if I pass 10 and then just print all the values instead of doing all this complex calculation. So let me delete them and I print I. So let's see what all values it prints. So I have to type range, not range. So range 10 and print all of them. If I print all of them in my terminal window, now what happens? It prints from 0 and you can see it goes up to 9. It doesn't reach number 10. So this is not going to fulfill my purpose of having to have replaced the thing which I wanted to do that. Now I can also have different way of handling range variable. So I need 2 to 9. Okay, that's my requirement. But to define, you can always say that from where you want to start. I don't want to start from 0 because I don't want to do a multiplication with 0, don't want to do a multiplication with more 1. It doesn't really make sense. So I want to do a multiplication, start my collection just like all nums on the line above. I can start from 2 and go up to 10 because 10 will be ignored and it will be considered for up to 9. So if I come over in my terminal window and run that, you'll find now my range will start from 2 to 9. So now going forward, I don't have to write any of these things which I was doing earlier, like creating a manual collection. So the collection will be given to you. I can simply say num multiply 1 I, and it will print all the values as is based on the number I provide. So it is the multiplication table for 7, 14, 21, 28, 35 up to 63. So you can see that it basically creates the same output, but the way I have written is more concise. Now if you ask me, like, give me a multiplication table up to 99, I simply go ahead and make it 100. Okay, I don't have to type all the elements or the values of till 99, and it is much more efficient and error proof. So you don't need to have worry about missing out an important one. It's so overwhelming output, but you get the essence out of it, right? So I'm free to do all sort of crazy calculation like up to 1,000. I can do that, and it's just a character difference in my programming, and then it'll give me all the values. So you can see that it'll keep printing all the values in the console up to 999 and multiply that with number 7. So you're basically getting a multiplication table of 7 which can multiply 7 with till 999, right? So that's the output you get. So you can imagine the power of this kind of built-in library functions, which helps us to focus more on what is our primary goal is rather than focusing more on the basic primitive stuff. So this is range. Now you can jump a range. So we have done, let's say, up to 10. So let's go back to the simple one. But I want to jump by 2 numbers. Okay, so it will start from 2 and with a step 2. So that's the last index is called step. So step is basically like how many jumps you need. By default it is 1, but you can explicitly say 2, 3, 4, so on and so forth. So you can define the step by yourself. Now if you say so, what will happen in the multiplication table? Let's notice here. It prints 14, 24, 42, 56. So clearly the numbers are 2, 4, 6, and 8. Okay, within the range. Starting from 2 with a jump of 2, you get only the even values. Okay, so that's how you can play around with things. So you can change the behavior of a range also and build a range to get only the even numbers out of, let's say, a collection of values or a range of values. And you get that pretty easily, and then it'll be available to you quite effectively. Any question before we move into the next type of loop? Okay, no question. So I'll go to the next type of loop.
Riju, লুপের আগের ইয়েটা আরেকবার একটু রিপিট কর, রেঞ্জটা যেটা 2 থেকে 1000 পর্যন্ত।
Range.
Range 2 to 1000, the previous range you demonstrated na. Please repeat, please.
Okay, got it. So range. So let's say all nums. So this is a variable all nums, and I need this all nums as a collection of numbers. Okay, range is only for numbers, by the way. So let's put it that way. Sequential number. Now, if I have an option to define a sequence by myself, so I can say 2, 4, 6, 8, 10, something like that. Or I can use something like built-in. So I can say all nums, and then I can just go ahead and change it to 1. And all nums, it becomes something within a range. Now, range is a built-in Python function given to us, and it accepts few values. Now, the default parameter value you need to provide is a stop. So where it will stop. So if you say that it stops at 10, that means this range will create a collection starting from 0 up to 9 sequentially. So which means that if you just simply print, so let's say I say for I in all nums. Okay, so that means I'm getting each element within all nums collection. That is, in this case, it is the same set as I defined earlier, but in a different way. And then I print, and I say that I want to print the I. So what I will get is that I will get 0 to 9 in the list. So let's see how that looks like. So if you just print that, you will say 0 to 9. So only providing one value within a range means that you start from 0, go up to that number, minus 1, and increase by 1. That's the default behavior of a range. But you can change the default behavior, because I'm not interested in 0. So I want to start with 2. Okay, so I start with 2. I go up to 10, which means that it will go up to 9. It will start from 2 and it go up to 9. So if I print that, we'll see that now it is not printing 0 anymore, 0 or 1. It starts printing from 2. So now the range starts from 2. So I can tweak the behavior of a range by defining what is the start point. Okay. Moreover, I can also say that I want to jump or have a sequential increase by plus 2. Okay, so the first number will be 2 plus 2, that is 4 plus 2, that is 6, up to 9. Okay, so we will only go up to print up to 8. Now, this is not solving my purpose, as I wanted to declare a set which will be like 2, 4, 6, 8, and 10. That is line number 2. So to do that, I can just go a little more than 10, because I need to reach 10. I'll say 11. Okay, so if I do that, then this sequence will have the exact same set as it is in the previous line, that is line number 2, that is 2, 4, 6, 8, and 10. But I don't have to manually calculate by myself to do that. What if that number is a bit more higher? Then you need to do a calculation, make sure that your calculation is correct, and do all sort of things. So for example, if I go up to 100 and I want to increase this by 11, now the first number will be 2, second number will be 13, 24, and so on and so forth, right? So you will find that this is doing the automatic calculation for you. So you don't have to do those calculations. Create a collection by yourself. Using range, you can say where to start, up to what number minus 1 it will reach, and then what is the jump or the step. We call it step. Step is by default 1, but you can alter the behavior of a step by defining your number, which must be smaller than the maximum, which is how much it must reach. The middle number, that is 100, must be less than 100, because otherwise that makes no sense. It will only print one value. If you have the step A as 200, okay, because it will not have 2 plus 200 within that range. So imagine that way. So you can actually build the collection of numbers, sequential numbers, using the range variable or range function, which is given to us by Python library. So it is not something we need to write, we just need to use it. Okay, this is the built-in library feature for Python. And this is very useful, by the way, especially in many different kind of calculations. Okay, then we'll go to while loop. Okay, so there is another way of doing loop, and as I have already written, that is called while. So it's like, if you think from a typical language perspective, right? Normal spoken language perspective, written language perspective. When I write while, I intend to say that that is happening, something is happening, right? So this is also a similar kind of loop. Unlike the for loop, where it takes a collection and go, let's say, sequentially from existing data set. So when you say that our range of numbers starting from 0 to 9, and I run a for loop, that for loop will go each and number, and it ends when that collection ends. So for loop doesn't need any end. It will automatically end when the input collection ends. This is different in while. So while, you need to explicitly end that. How do you define while? So let's say you define n equals to 1. That's just a variable called n. And then you say while. Now while is a keyword. You can see that it's becoming blue in color. And then I say n greater than 11. And then while starts. And then I say print. And then I say n. Now what happens here? It will keep printing n forever. Okay, that's what we call as infinite loop. So with the while, there is a danger of infinite loop. When there is a danger of infinite loop, your program logic stuck there because it keep on doing something which you don't intend to do. It is quite annoying at times. Now you need to make sure that you increase that n. So how do you increase the n? So you can say that n equals to n plus 1. So you basically get this increase. And then I go here and then see that this is where basically my n is getting increased for the next step. So if we read this program, line number 6 says that the value of for the first time, the value of n is 1. Now print 1. It will print 1. That is fine. When it comes to line number 8, the value of n becomes 2. And then it prints 2 for the next time. Now the next time it will print 3, 4, 5, and so on and so forth. And when it reaches number 11, it will print nothing. It will only work when the value of n is less than 11. Okay. Now you can see that this is my own sequence. There is no existing collection or set of data I need to iterate through. So this is not iteration, unlike the for loop. This is a loop based on my need of the moment. Okay, need of the hour, if you want to say it that way. Now, if I print this while loop, what I'm going to do is that I'm going to print that, and then I see that I have 1 to 11. sorry, 1 to 10, because I did not consider 11. It's not n less than equals to 11. I can have that also. So I can put a condition less than equals 11 and will print 11. Okay, so I'll show you that. So you can have your own condition that way. So you can see that n equals goes up to 11. But let's say I want to print only up to 10. Okay, so I basically build a while loop running for 10. Now if I do the same multiplication table for 5, let's say, and do it in the while loop, and instead of this I say num star n. What it is going to do is that it is going to build a multiplication table for 5 and do all the calculation for me. Now it is not for loop. It doesn't require a collection. I don't need a range or something like set, tuple, or list. I just build a logic. Now if I want to jump with 2, so let's say I want to only print the even, calculate the even number. So I can start with 2. I can increase by 2, and then it will print only things which are 2, 4, 6, 8. Right, so you can see that the behavior changes based on that. So if I just want to show you what are the values, simply probably I can change this 5 to 1, and it'll just simply print all the n's in the while. So n's are basically 2, 4, 6, 8, and 10. So you understand that that is a different way of defining a loop. But the thing is that termination has to happen by you, because it doesn't take any collection as an input. It will never end unless you go ahead and put a proper option to end. Now why it is ending? Because I have mentioned that n do this while loop till n is 11. Okay, that's what I put a condition. Assume that I don't increase n by any number. Do this. I forget to write this number, line number 9. If I forget to write this line number 9, now what will happen? This while loop will never end, because it will keep on doing the same thing again and again. And in programming language, you can see that I'm not stopping. It's just happening. Okay. In programming language, this kind of behavior is known as endless loop or infinite loop. And these are the let's say the blockers of any application. So if there is an infinite loop within an application, it will never move to the next instruction, right? So that will stuck there, and probably you will find something like a block in the application, or it is not doing what is expected to do, and all sort of things. So let me just stop this forcefully. Okay, so I just interrupted by Control Z, and I show you the output. So I just scroll up, you can see that it just kept on printing things. Okay, so it just kept on printing things. So it just didn't mean anything at all. So let me clear it up. Now you can see that the while loop is too dangerous if you miss this condition where it'll do something different. So n will always be less than 11 no matter what you do, because you will declare a variable n with 2 and you never change that value. So it'll always be 2, and whatever we're printing inside that will keep on doing. So in this case it is print. In another case, if it is, let's say, sending an email, if your application tries to send an email to a customer for thanking him to, let's say it's a banking solution, thanking him to do the banking for an year, an anniversary sort of email, and it will send probably a few hundred thousands of email to that customer, and next day customer will come and close that account in your bank. It's too dangerous. Okay, so you have to remember that this is too critical for us to really make sure that it has a logic built in which makes this loop to die after some time once this activity is done. It can be long, it can have many different things, but it should end, it should break. You can explicitly break also. So for example, I want to calculate till when n is 112. Okay, so those many numbers, but I put a condition over here saying that whenever the value of n is greater than 10, then I end this thing. So if I say if, and I put a condition, n is greater than 10, then I can say break. Why I wrote this, I can write it late after also. Why I wrote this is just to show you how this indentation makes a difference. So if I say break and just stop it, break is also a keyword, and I enter it, and I want to show you that here the if is in this column. If I put a down arrow, the print is in the same. So print is definitely not inside the if. Okay, to have the print inside the if, you need to put a tab and then move the print little further. Okay, but we are not doing that, so we are not going to move this into a next thing, right? So what I'm going to do is that I'm going to check till 10. The moment it is more than 10, that neither it will print nor it will do anything, but it will also come out of the loop. Okay, so the loop, even if the loop says that it can run up to 112, but it will actually run up to 10. Okay, so let me show that and run it. So this is a if condition within a loop. Okay, you can see that it is only running. Imagine that I do not have this, and then I probably also hide this, and then I print this. What will happen? It will print all of these values up to 110. Okay, so you can see that it is going to do that, the thing, right? So you can imagine that it is basically controllable loop, even if the loop is longer. So in many calculation, you don't have to complete the whole thing. You got the result, you come out of that. Okay, so for example, if I consider having, let's say, last 10 transaction in a bank, you provide an input of last 10 as a number, and you may have hundreds and thousands of transactions. If you're an age-old customer of a bank, then bank will only get you the latest 10 as a mini statement, and it will ignore remaining other transactions. So that is where loop comes quite handy, and you can actually control the behavior. You can even, let's say, instead of saying break, if you want to let this loop happen, but say, let's say, instead of breaking, you can say pass. Now what happens? This whole thing will continue to happen. It will not print the norm. It will just pass on to the next thing. Okay, it will keep on passing to the next thing. Right, I'll show you the behavior here a little differently. Okay, so I print two things. I change it to 5 so that you see a different value. I print the value of n here. Okay, and I print the result here. So you will find two values, and then I just reduce it to, let's say, maybe 15. Let's make it a little smaller so that we identify what exactly happening. Now here, this will go through the loop for all the values. Okay, so we are increasing now by 1, let's say. So starting from 2 to 14, it will do the calculation. It will only print up to when it is 10. It will keep on going into the while loop, but don't do that calculation. That's what it's going to do. Okay, let me show you the output. If you run that, now you can see that it is printing all of them. The reason behind the if statement is independent, but the print is within the loop, and that's why the indentation is so important. But this output is not at all my expected output. Now, why it is not happening?